Okay, so here is page 4 of your Chapter 8 study guide. We're going to be talking about the circumference and area of a circle. So this should be a bit of a review, this first part here, but then we're going to start looking at finding just a specific part of a circumference, which we'll call an arc on the circle, and a specific part of the area, which is called a sector of the circle. Okay? So a circle is always named by its center. So over here we have circle C, okay? So it's always named by its center. The area of a circle can be found by the formula pi r squared. So r, you need to know, is the radius. Okay, so r is always the radius. And if you ever see a lowercase d, that means it's the diameter. If you remember, a radius is half of the diameter. So a diameter would go all the way across through the center. That is the diameter there. Okay? But the radius is half of the diameter. So 2 radiuses multiplied, so 2 times the radius equals the diameter. Or the radius plus the radius is the diameter. Okay? So the circumference of a circle is essentially its perimeter. So it's how far, like if I were to cut this circle and then lay it out flat, like the outsides of it, so if I had a piece of yarn in a circle and I instead cut the yarn and put it as a straight line, that's its circumference. So it's essentially its perimeter. Okay. Now the circumference of a circle can be found by the formula 2 pi times r, or simply pi times the diameter. But more often than not, this is what you will see as the formula for the circumference, 2 pi times r. So here we're going to look at a few just definitions. An arc is a connected part of a circle. So the arc is just really, it's part of the circumference. So we're going to write it's part of the circumference. Okay. And a sector is a slice or region inside the circle bound by 2 radii of a central angle and the arc between their endpoints, right? So it's essentially just a part of the area of the circle. So we're just going to write part of the area. So instead of calculating just the entire area, we need to know the full area and that certain part of the circle. So you would multiply it by whatever fraction that part is of the circle's area. Same thing with the circumference. We're basically going to identify and determine how much the arc is of the entire perimeter or the circumference. And then that's what you're going to multiply the whole circumference by. So let's go ahead and see down here, there's a few more definitions. So the area of a sector is a fraction of the area of a circle with the same radius. So it obviously has to be within that same circle from the center out to the edge of the circle, and that is the radius. So in order to determine what the fraction is, you have to know the angle measurement here of the sector. So the angle measurement of the sector determines the fraction because a circle is always out of 360 degrees, right? So that is why it's always going to be determined by the angle measurement. And then we're able to write a fraction from something over 360. Now the arc length, which was part of the circumference, it is a fraction of the circumference of a circle with the same radius. So obviously it has to be on the circle just like this one is. Once again, It's going to be the angle measurement of the arc that determines the fraction. So usually a problem will either tell you the angle here, some x degrees, or it's going to have a sector drawn here, and whatever this is going to equal, let's say it's x degrees, it's going to equal the same degrees as the outside. And sometimes you guys might see something like this, which is a different type of angle, but you see it still makes this same arc here. Now, whenever this is the case, that means that this, whatever this measurement is, this angle here is half of it. You can think that, oh, it's farther away, so it's going to be half of that. So let's say if this one was 30 degrees, then that means this one out here would be 60 degrees, and this one here is 60 degrees. So these are just a few different things we are going to run into. So I just want you guys to make note of that here. So what we can specify here is that the central angle of the arc determines the fraction. And in all honesty, I should probably specify that here as well, just so you know exactly what angle I'm talking about. Here as well, it is the central angle that determines the fraction. So the central angle is right here, okay? Wherever the center is, that's where the central angle is. So again, it's going to be something, oops, let's change that. It's going to be something out of 360 degrees, because again, it's still a circle. So let's put this to use here, okay? We're going to go ahead and do this circle here on the left. First, it asks us to find the area of the circle. So we know that the formula, what colors did I use for area? Oh, I didn't. Okay. So this is going to be a sector, so we'll use orange. All right, so the area of the entire circle is pi r squared. So first thing is to identify what r is. Well, our radius here is 8. From the center of the circle to the edge, the radius is equal to 8. So we can rewrite this as pi times 6, oops, sorry, got ahead of myself there, 8 squared, which is pi times 64, which we can rewrite as 64 pi for now. You could always multiply this out. You'll get a decimal, but you don't have to do that right now. So if this is 60 degrees, right? 60 degrees is what fraction of the circle? I believe this was supposed to show 60 degrees here, so make sure you jot that down. I'm going to write that in white. So 60 degrees, if we were to write the fraction, it should be 60 out of 360. And we can always reduce that, right? Both the top and the bottom here are divisible by 60. And if you didn't see that right away, you could divide it by 10 and then by 6 after you divide both sides by 10, or both top and bottom by 10. 60 divided by 60 is 1. 360 divided by 60 is 6. So the area of the sector is always going to equal the fraction times the area of the whole circle. Okay, so here our fraction is 1/6, and our area is 64 pi. Okay, we can multiply those two together by putting this guy over 1, and then you just multiply straight across here and here. Okay, so this is going to be 1 times 64 pi is 64 pi. 6 times 1 is 6. And then again, you might see this as a reduced fraction on the test. So to reduce this fraction, we see that they're both divisible by 2. So this would be 64 pi divided by 2 would be 32 pi. 6 divided by 2 is 3. And this is also about equal to, so if we were to take this into Desmos calculator, 32 pi over 3 we get about 33.51. Okay. And here it doesn't tell us like if it's in inches or centimeters, but let's just say that I declare right this second it's in inches. Okay, so for area you have to write as inches squared. So this is the area of the sector. Area of the sector is about equal to, here, is about equal to 33.51 inches squared. If that 8 were in inches, we're just going to say it is. Again, you might also see it as 32 pi thirds inches squared. These two things are equivalent right here. Okay. So now let's go and do the circumference of this circle. It's a new one. This right here should be 120 degrees. Okay. First, we have to write the circumference formula. So the circumference of a circle is 2 pi times r. It asks what 120 degrees is what fraction of the circle. So this right here is the central angle. It's 120 degrees out of 360 degrees. These are both divisible by 120. 120 divided by 120 is 1. 360 divided by 120 is 3. And I mean, honestly, if you end up just making it into a decimal anyway, you could just leave it as this and then multiply that by the circumference. That would work as well. So here we need to be specific that to find the arc length, you have to multiply the fraction times the circumference of the whole circle. Okay, so we need to find the circumference. So it looks like my radius right here is 5. That is my radius. So the circumference is 2 times pi times 5, which is just 10 pi. You always want to put the number in front of the pi. There we go. 10 pi. Okay, so that is my circumference. And my fraction of the sector of this arc here, so this is the arc that we're finding the length of, that's only 1/3 of the circle. So this is going to be 1/3 times 10 pi. Now if we put this over 1 times 10 pi is 10 pi. 3 times 1 is 3. So that essentially is the arc length here, but you can also make it into a decimal. So we can do 10 pi divided by 3. You get about 10.47. So the arc length equals 10 pi over 3. And again, we should have some type of unit. Let's assume this one is in centimeters. So it'd be centimeters. And it's not squared because it's not an area. It's just the length here, which is about equal to 10.47 centimeters. Okay, so that would be your answer for this problem. And again, you can see it either as the fraction or as the decimal, so make sure you know how to simplify down both ways. All right, so let's go and do a practice problem down here. So here we're given another circle. We see here that the radius is 8 centimeters. Okay, so that is my radius. And the angle of this section here, of angle ACB, is 30 degrees. So as I see this, I notice I'm like, oh, okay, well, since it's on a straight line, then that means I can find this part of the angle as well if I need to. So let's see if we even need to. We might not need to. So it says here, for a circle with radius of 8 centimeters, find the following and clearly show all steps in your calculations. Here it says use 3.14 for pi and leave the answer to the nearest tenth. So that's really important that you pay attention to that, because whether you round pi to 3.14 or just use the pi button, you will get a slightly different answer. So you always want to read the instructions and make sure you follow those. So first, let's find the area of the circle. The formula is pi r squared. We know that the radius is 8. I'm going to highlight where the radius is. So they told us here, but we also saw it here as well. So this here is the radius, and that's what I'm plugging in here. 8 squared is 64, and we still have the pi. And it says to use 3.14 for pi. So we're going to do 64 times 3.14 and see what we get here. So 64 times 3.14, we get 200.96. And this one's kind of difficult to round to the nearest tenth, so I'm just going to give you guys permission to round it to the nearest hundredth. On the test, you guys will never get anything like this specific. Yeah, like you'll be able to choose from the multiple choice questions, or multiple choice answers, which one is closest to your answer. And since this is area, it is squared. So this is the area of this circle. Basically, like if we were to round this one, we would end up rounding this to 201, but I want us to still have some decimals in there. So now the circumference of the circle, that is basically just the perimeter around the edge. The circumference formula is 2 pi r, and we know that the radius is 8, so it's going to be 2 pi times 8. Okay, so we have 2 times 8 is 16. We still have the pi. So that is our circumference, but we want to use 3.14 for pi. So if we put this into the calculator, we have 16 times 3.14. We get approximately 50.24. If we were to round that to the nearest tenth, it would just be 50.2. And here we have centimeters. And it's not squared because we are not finding the area there, it's just the length of something. Okay, so now we're asked to find the area of the sector bound by the central angle ACB. So if I were to draw ACB, this is the angle right here. So this is the sector that we are going to find the area of. So again, the area of a sector is equal to its fraction times the area of the circle. So anytime you see a capital A with like a word next to it, that's saying area of that something. So we have to find our fraction. So the fraction here is we're going to use the 30 degrees. So the fraction is 30 degrees out of 360 degrees. Now you could always leave it like that if the answer is just a decimal anyway in the multiple choice part, but I always like to simplify. And you should know how to simplify. So if this is something you struggle with, that's something you need to look up and review or ask me for help on. So looking here, I know they're both divisible by 10 and by 3. So that means I can divide them by 30. 30 divided by 30 is 1. 360 divided by 30 is 12. So I know that my fraction is 1 over 12. So this part over here is 1/12 of the entire circle. So the area of the sector is going to be 1/12 times the area of the circle, which is 200.96. Okay, so now if we wanted to multiply that together, we just have to put this one over 1 and then multiply straight across. 1 times 200.96 is 200.96. 12 times 1 is 12. I'm going to move this part down here a little bit over here. So if we were to put this into the calculator, we have 200.96 divided by 12. we get approximately 16.74. It asks us to round to the nearest tenth, so we're going to do 16.7 as our answer. So this is about equal to 16.7, and since it's area of that sector, it's going to be centimeters squared. So this is the area of that orange shaded region there. So now if we're trying to find the length of arc AB, the length is circumference, but we only want to find this part of the circumference, the length AB. So it's very similar to the area of the sector again. So the arc length is equal to the fraction of that arc times the circumference of the circle. So this is what you'll use every time. So in this instance, our fraction is over here. It's 1/12. It's the same arc as what the sector was, so we don't have to do any more work for that. We already know it. Because that was 30 degrees right here. So that's also going to be 30 degrees. Now what I had kind of shown you guys earlier was if you have something that's like the angle's way out here that creates it, then this angle here would be 15 degrees, so this one would be 30 degrees. So no matter what, like if you have something that goes all the way across, it's half of whatever the outside is, but then it's also half of the central angle. So just so you guys know that that's how you would tackle that part of it. So our circumference, we got 50.2. Again, we can put this over 1 and then multiply straight across. 1 times 50.2 is 50.2. 12 times 1 is 12. Now if we plug that into our calculator, we're going to do 50.2 divided by 12. We're going to get approximately 4.18. Now that 8 would round up the 1 that's in the tenths place to 2. So our approximate answer is going to be 4.2. And it's just centimeters because it's just the length of an arc. So just like circumference, you guys do not square something that's a length. You only square the units on something that is the area. So this should help you out to your Khan Academy. If you want to get a head start on Thursday or Friday's work, depending on what class you're in, you can definitely start doing these circle practice problems. These are really, really good practice for everything, okay? And then we'll do the rest of this study guide by the end of the week. All right, so if you want to get a head start, again, start trying out these problems, and then you can just use my future video to